Hi, I'm at Bett 2026. I'm here with Harry at the Scan booth. Harry is the Robotics and AI Lead for Scan. And Harry, you've been showing me the Dobot robotics products. Tell me about them.
Yeah, so we've got a bit of a range here from the sort of most simple My First Robot style, which is 4-axis, so it can only sort of move within this plane.
It's this one here.
Yeah, which we showed earlier how easy it can be to program. And then here we've got the Magician E6, so this is a 6-axis machine, meaning it can move on a lot more axes, so it can have sort of full dexterity. And we've got it coded up here to play Connect 4. So we stuck a camera on the end, and then we're using a combination of a AI computer vision model trained in NVIDIA Omniverse,
Right.
and some Python coding to teach it to play Connect 4.
Now, what's really cool about this is this unit here is like a smaller version of the big factory robot arms, right?
Yeah,
it's the same
exactly.
industrial robot.
Exactly, and it has the same precision, and for small tasks, these are used in industry. And programming them, it's the exact same toolkit as the huge 10-foot tall robots.
Right.
So going from these and scaling up to industrial tasks is a very simple process.
So if a lab or a university or even a school was teaching robotics, it would mean like the software stack that they're using and the hardware is exactly what you would use in the professional environment, right? You would
Yeah.
it would be the gateway to the proper stuff.
Yeah, exactly, and they even sell miniaturized conveyor belts. So you can create an entire factory floor, essentially, with conveyor belt moving parts on there with these sort of robots, test out your systems,
Yeah.
prove it out in small scale, where it's much cheaper, and then if that works, you can then grow to industrial-sized robots and conveyor belts and systems.
That's cool. So now this arm here, I've just seen it pick up its piece.
Yeah.
So there are a couple of eyes at the end here, right? You've got two cameras, that's the robot's eyes.
Exactly.
So that's the computer vision part.
Yeah, exactly.
Where it can recognize objects in 3D space.
Yeah, and it's two cameras, like we have two eyes.
Yeah.
So we can use the difference in the two images from the left and right eye to work out the distance, and that's how it's telling exactly where to place it in the board, and it knows how far to move and how to pick up the pieces.
And even if I've nudged this slightly, like
Exactly.
say I've bumped it or something,
Yeah, exactly. If you put
it'll still
yeah.
know where it is because it's got the
Exactly, so it's
stereo
constantly
vision.
updating, it's got a feedback loop with the vision. So rather than going to a fixed point like traditional robotics often has been,
Yeah.
where it goes from point A to point B, and it relies on the object being in the right position for the target,
Yeah.
using the feedback loop with the cameras, it's using AI to actually recognise what the system is and do the task correctly rather than just do a pre-programmed task. So if you place your next token in there,
It's waiting for my go,
yeah, it's
right?
waiting for your move. It's not a cheater. So now we can move this.
And it knows not to drop it
Yeah.
until so now it knows where it is. I see. It's tracking it all the time.
Exactly. So
Yeah.
it'll follow it and then release it at the right point when it knows it's in the correct position.
Now, how does it know which piece is its piece? How does it know it's playing red and I'm playing yellow?
So it knows like who takes the first move, that it's then the other colour. So we can put some yellow pieces down here and just simple colour recognition on the prompt. It's actually part of the AI model. It's trained on yellow and red pieces. So rather than recognising a counter, it
Yeah.
recognises a red counter or a yellow counter as separate objects. So it knows to pick the correct one up. So if we look at the screen of what it's seeing,
Yeah.
we can see the bounding boxes, the red and yellow and empty, are all different. So we can tell the difference between each piece.
And did the data set have to be 3D for these pieces? It had to be for the board,
Yeah.
right?
Yeah, exactly. So you have 3D pieces in Omniverse. So
Yeah.
essentially you have 3D models of these, which is a simple cylinder.
Yeah.
You create a 3D model of the Connect 4 board,
Yeah.
which isn't the easiest task, but it's much easier than collecting the data manually.
Yeah.
Omniverse then randomizes the positions, lightings, the layout on the board. You can stack tokens on top of each other to recognize it like that. And then it outputs a huge data set with perfectly segmented and bounding
So
boxed
that's
images.
a custom data
It's a
set.
custom data set.
Yeah.
Yeah, so traditionally for this sort of task, you'd have to take a few thousand photos of Connect 4, pieces in different positions. You then go through and manually click and mark every single piece, if it's red, yellow, empty pieces on the board, if a token's placed in there, which would take you weeks and weeks.
Right.
With Omniverse, you put the 3D models in there, you write a short script just to randomize everything, and then it will output as much data as you want. You just keep running and running and running.
Yeah.
In different environments, different lighting, different orientations, different camera positions, and then you have a whole very rich data set, which will train this model. So this had never seen a real Connect 4 board until it started playing. Another advantage of that is when you start going, and this happened with this, you realise actually you're missing some data points. There's some areas where it's quite weak. And traditionally, you then have to go back, set everything up, get the cameras out again. Whereas with this, I just go back into Omniverse. I say, oh, it's not very good when the camera's particularly close, like when it's about to shop a piece. So now I set up a new, I just adjust part of the script to randomize cameras a lot closer.
Yeah.
And then you get a new data in there, you combine it with the old data set, and then you can go retrain and fine tune that model. To iron out all the kinks.
So now you've been playing with this robot, or playing Connect 4 with this robot for the past few days.
Yeah.
Do you think it has a strategy in advance? And you've programmed the robot, do you think,
so
or is it just responding to like, right, there's 3 there, I'd better put a red there, which is what it just
plans
did.
4 moves ahead. So it's looking sort of 4 moves ahead. So then it figures out what the most optimum strategy is based on that. So we found that's a nice threshold. If you go to 5 or 6 moves ahead, it makes it almost impossible, and people can't win. If you go to 2 or 3, it's quite easy. So we found about 5 or 6 people a day are beating it, but most people struggle.
So it's not just reactive, it's actually planning ahead as well.
Exactly, yeah.
That's great. Well, this is the first time I've ever played Connect 4 with a robot. I want to have another go. Thanks so much for your time,
You're welcome back
Harry.
anytime, thanks.